Gabriel Nambila, and this presentation is my case study one for spatial database design. The article I picked to do my case study is called Securing Spatial Data Infrastructure for Distributed Smart City Application and Services. And so, before we dig a little bit deeper about this paper, we're going to go over the abstract. So, smart city are complex distributed system which may involve multiple stakeholders, application, sensor, IoT devices. In order to be able to link and use such heterogeneous data, spatial data infrastructure for smart city can play an important role in establishing interoperability between system and platform. Based on the open and international standard of the Open Geospatial Consortium, OGC, the smart city district data infrastructure concept integrate different sensor, IoT devices, simulation tools, and 3D city models within a common operational model. However, such distributed system, if not secure, may cause a major threat by disclosing sensitive information to untrusted or unauthorized entity. Also, there are various user and application who prefer to work with all the system in convenient ways using single sign-on. This paper presents a concept for securing distributed application and services in such data infrastructure for smart cities. The concept facilitates privacy, security, and control access to all stakeholders and the respective component by establishing proper authorization and authentication mechanism. The approach facilitates single sign-on authentication, but a novel combination in the use of state-of-the-art security concepts such as OAuth2, access token, OpenID, connect user claims, and security assertion markups language (SAM). An implementation of this concept for the district of Queen Elizabeth Olympic Parks in London is shown in this paper and is also provided as an online demonstration. Such access control and security federation based realization has not yet been considered in spatial data infrastructure for smart city before. And so, as this abstract say, this paper talk about how spatial data infrastructure can be implemented for smart cities. But in order to do that, it also needs to be done in a secure way because you don't want anyone to be able to access everything, and even people that are not supposed to see it shouldn't be able to access it. So what you want to do is develop a framework that will grant access to the right amount of people. So, for example, a citizen should only be able to see what a citizen is able to look, and someone taking care of the infrastructure should be able to see everything, and someone that doesn't have access shouldn't be able to see anything. And so, on this first figure, which is an illustration of different data source for Smart City in order to link user data to one infrastructure model, we can see that we have a user A, which is a municipality officer, user B, which is a citizen, and user C, which is a transportation manager. So, the municipality officer, the citizen, and the transportation manager shouldn't have the same security access. For example, the citizen, it should be limited to what is related to him. The transportation manager can be traffic, maybe weather, and the municipality officer should be able to see everything. And so we can see that from there, there's a distributed application such as city dashboard, air quality application, energy portal, weather application, disaster management portal. And for example, the citizen shouldn't be able to see management portal or the city dashboard because it's private information. But even when you go a little deeper into that, in the distributed resource layer, we can see there's the analytical tools. There's sensor one, 3D city model, sensor two, and analytical tool two. And at this layer in particular, it should only be reserved for people that take care of the infrastructure. Again, it shows you how important is the security model in smart city application. And so the way it works is this illustration show how secure and control access to the distributed application services within the framework. So you can see that the the weather station, the background map, the thematic application attribute, and the 3D district model are all aggregating toward the service catalog registry, which allow people to do that. But someone that doesn't have access, for example, to smart meters, won't be able to do that because to see those information because they don't have the right access, which is how things should be. And here, this Venn diagram illustrates the key focus of this paper. So SDI stands for Spatial Data Infrastructure, Smart Cities, and Security. And so this paper what cover is the contribution or where spatial data infrastructure, security, and smart city. Uh, that's where the contribution is made. And so on this representation, we can see how the framework works. This is a screenshot taken from 3DCDDB WebMike client developed by the Technical University of Munich. And you can see that there's a direct link to SOS, thematic data from WF, and automatic detection of parsing given thematic data source, such as Google Fusion, Table, and WF, and etc. And so such a map shouldn't be made available for the citizen because they might modify, mess up the data. This should be only restricted to high city official or engineers that work with this data on the daily. But still, though, it's still part of the overall infrastructure. It's hidden to people that shouldn't see it and people that should have access to it. And so, this paper covers some really interesting point that I wanted to lay out. So it covers like what are the requirements for a smart city. Also, requirement one is first, you need to have different stakeholders. You cannot just build a smart city for one group of person. It should be the citizen, city official, mayor, politician, engineer, and young professional. And requirement two, need to have a distributed application. So the application cannot be sitting on one layer. So for this case, the application should be sitting on a cloud, for example, where a lot of people can access to it at multiple times, but all those people don't have the same security and access control. They call it IAM policy uh, to determine which access they have. In requirement two, you should have a simulation and analytical tools because with all those data that you gather, you should be able to simulate what's happening on your city and analyze what's happening, but also have virtual twins to understand what is lively happening. So let's say if on the main highway there's a congestion, you should be able to see that and find ways where you can alleviate this congestion, maybe by redirecting some people taking other roads, for example. And requirement four is sensor and IoTs. So you should have a sensor all around your city to capture the weather, temperature, city movement, and more. And which is really important because that's the only way where you can transfer what is happening with your physical asset to your digital asset. And requirement five, you need to be inclusion of geographic information, and that's something I actually learned reading that paper because I feel like I always didn't think about that. Because when you think about smart city, you always think about the buildings, the road, the car, and the people, but actually the geographical location is really important. Is there mountain, is there hills, what is under the city, what is the what geotectonic plate the city is sitting on. I feel like all those information are also important because it's part of the physical asset. And requirement six, interoperability, which is an important thing. And requirement seven, it need to be open to international standard. So you need to make sure that the security measure is something that's recognized worldwide, because this. entity that manage all those systems, you need to make sure that you follow those guidelines so you don't get in the future or you have some data leak, which can cause your project to crumble. So even though you're building this project on a local level, it's important to see that, oh, am I following the international guideline, so you don't get in trouble into the future. So I feel like especially now, you can see like all the different layer that take to be a smart city, such as politics, technology, geographical location, user, system, infrastructure, cloud, database. It's just everything is important. And requirement 8, you need to be linked component. So with all those information, those sensor, those people, you need to be linked in a framework where make it easy to understand what's happening. And requirement 9, you need to have authentication and authorization, because you don't want the wrong person to be able to see what they're not supposed to see, but also you want to make sure that the citizen or the regular people can see what they can see. And also you want to protect your infrastructure to make sure that there's no data link, and only the right people are able to access certain amount. So let's say you don't want a citizen like me to be able to see what, for example, the president is doing, or um, where is like what are like a bank information, for example, like the password, or find a way to like steal bank authentication so I can crack in, do all those bad things, like to prevent criminals, for example. And requirement 10 is you need to have user information. So you need to build a database, a secure database that gather information about all your user, because they're part of your city. So you need to have the age, the profession, what they do for living, where they usually go, what access they have, what they can and they cannot see. And they need to have this. And requirement 11, you need to have a single sign-on, because it might, let's say you need to have like 10 sign-on, just to you have one sign-on to go to the bank, one sign-on to go to a movie theater, one sign-on to do all of that. At the end of the day, it's going to be really tedious. So with one single sign-on, you alleviate all of these needs. What a user or an engineer or an architect will only need is only one sign-on to access all the services with the policy that they have, with the authorization that they have. And requirement 12, the single sign-on with delegate authorization. So all single sign-on should be equal. Some people should have more access, some people should have restricted access, some people who are not supposed to have access shouldn't have any access. And that's how you protect your infrastructure. And so here is kind of illustration showing how the security scenario works. So you can see that a user that's logging into the system, they can access to the three map application, the thematic attribute, the weather station, and the smart meter. But a user that's not logging in using the single sign-on, they shouldn't have access to all some of those features, for example. And by them logging on, you can even track on what they do, which is really important. And so here on this table, it kind of showcase all the different stakeholders that we mentioned before, that you cannot only build a smart city for one particular group of people, but you building for like application, cities, and everyone. So you can see that a smart city information framework have different requirements, such as stakeholders, application, simulation, sensor IoT, 3D city model, interoperability, open standard, link access, security, privacy, single sign-on, and all the specific single sign-on that they have. But also you can see that all those different research work needs to be able to match all those requirements. And so some of these don't, for example. So when you see the triple A approach, there's a lot missing. But what this paper cover is covered everything that's needed, all the requirements, which is really important, because you don't want to forget it, because you don't want to breach into your system. You want to make sure that your city and the infrastructure and the framework that you're building is really safe and available and secure and always up to date, and there's no breach into it. And so here, I found something really interesting. So here is like a selection of appropriate identity provider to access the resource. So what they did here, right, for this paper in particular, they separated what type of identity provider needs. So for the regular people, they just can log in using the Google email. So that's how we know. Oh, that's a citizen. They use the Google email. That's the access that they have. But for example, someone working at the university, he will log in using a different user credential so he can access things to that university. And because he used that single sign-on, it will be good to access building, to go to places, because you don't want someone logging in using a Google to be able to access the university, which may be bad. Like they can steal information, walk into classes, and you won't be able to track it. And also you can see different things. So this page is a single sign-on a single point page, but when you get there you pick which sign-on that you want. So if I work at the Academy of Art, I will sign on using the Academy of Art, and after that all my authorization, I can walk into the building and do everything I need, which is amazing. And so here, it's a figure that illustrates a step to perform authorization, authentication, and single sign-on. So you realize that for the least important thing, you don't need that much sign-on. But for really confidential information, that's why you have different layer of sign-on, which is perfect. Because you don't want to make it difficult for someone that's trying to simply use the application to have to sign on to all of these things, or make it simple to just go there. But again, right, this is built on a single sign-on platform, but it's like I want you to imagine it's like a building, right, with different gate. So the easy information, you just need to pass gate one, but for the high confidential information you need to pass, for example, 5 gates, which makes you it's really secure. And so by reading this paper, it really opened my mind on what it takes to build a smart city, because it's not only the building, the citizen, and just calling it smart and just having a bunch of text around, but it's a way to integrate that in an intelligent framework that makes sure everything's blended, and taking into consideration that everything is always secure, and that the right people can always access what they need and the wrong people won't be able to access what they need. But also it shouldn't be something that you just wake up. You need to understand what your stakeholders, what framework you're going to use, what is the level of security, and how you can integrate your geographical location, your city architecture, your citizen, their data into one single framework that makes sure that you're able to track, run analytics, and also have a digital twin of your city to understand what's happening live, so you can make the more efficient decision when it's needed. And so that was Gabriel Nambila for my first presentation for spatial database design. Thank you.